Hi, this is Doug from Zegami. Today I'm going to be walking through our breast cancer imaging collections, which show abnormalities in breast tissue mammograms. We have two different collections of this data, one showing the full mammography shots, as you can see here, with these regions here indicating where the abnormalities are on these full shots, and one collection showing close-ups of the abnormality regions, so those actual cut-out regions. All of the data and images and masks indicating the locations of these abnormalities have all been sourced from a dataset hosted by the Cancer Imaging Archive. So let's dive in. Zegami is a platform designed to make exploring and getting a feel for your data easy and intuitive. So we have 3,486 different abnormalities in this collection, represented here by that many images. And we can focus on individual samples to see any associated metadata with the images. And yeah, while this is interesting to see, we are more interested in the abnormalities themselves for this collection. So let's swap over to this collection. Now, while it's nice to be able to see everything at once, it's not an entirely intuitive or ordered way to take in the dataset. If we switch to our scatter view and take a look at the images using Zegami's image clustering, we can see the dataset in a whole new way. So images here are placed in 2D space based on their actual image content. Similar abnormalities are placed closer together in clusters using unsupervised machine learning, providing a much more intuitive layout. Using only what the images look like, Zegami has separated the abnormalities into two fairly distinct regions. So if we go and overlay the abnormality type, this dataset we can see contains calcification and mass types, which are included in the metadata. So this separation has been made purely on the content of the images. The platform has not consulted the metadata to place the images in this map. So it's interesting that it's managed to successfully separate these into almost perfectly the two different types actually contained within the dataset. So let's take a look at this calcification cluster over here. We can go in our filter tool and just lasso this region. And within this group we can dig a little deeper by looking at the pathology entry that came with the dataset. We can see it's got benign without callback, and malignant. Let's actually overlay these types as colors on top of the images. Interestingly, there appears to be a slight visual pattern to this, and we can see a region of calcifications down here that tends towards being benign without callback. So let's filter to just this region. And bring it back into grid view. So we can see that there's a few non-benign without callback items here. If we want, we could graph this and we could see how many there are kind of bleeding into this region quite easily. But let's just take a look at these benign without callback items. So without really knowing what to look for in just a couple of minutes, as someone that isn't a clinician, I've drilled down to a fairly interesting subset from a large collection of mammography images.